Look, in 2026, CICD is no longer just some nice-to-have automation script running in the background. These pipelines are the literal assembly lines of modern tech companies. Choosing the wrong foundation means you are signing up for years of crippling technical debt. And yet, if you look around, engineering forums are still absolutely filled with teams struggling to make this call. Should teams still be using Jenkins, or has GitHub Actions effectively become the undisputed default CI/CD platform? Well, let's break it down and find out.
To truly understand how we even arrived at this crossroads, we really have to talk about a concept called platform gravity. Basically, this principle dictates that the best CI/CD tool is almost always the one sitting closest to your source code. Historically, CI/CD evolved from this sort of niche manual automation into an absolute backbone of our infrastructure. But as engineering teams scaled up, the friction of connecting a standalone, separate CI server to a distinct code repository became this massive bottleneck. We all know developers absolutely hate context switching. I mean, forcing an engineer to jump from GitHub, where they're actively reviewing pull requests and in the zone, over to a clunky, entirely separate Jenkins UI just to watch a console log spin, it creates massive cognitive friction. When your pipeline is native to your code host, authentication is automatic, and the whole developer experience just becomes completely seamless.
Now, let's actually look at the numbers for a second, because the 2026 market data shows a deeply divided landscape. On one hand, GitHub Actions has captured an astonishing 68% of the open source and startup market. I mean, startups overwhelmingly choose it because, let's face it, they don't have dedicated DevOps hires yet. They just need automation that works straight out of the box today. But look at the other side of the equation. Jenkins still retains a massive 40% hold over the enterprise CI/CD market. You might be wondering, why? Well, because Jenkins is just deeply embedded in complex legacy environments. We're talking enterprises with strict compliance rules, custom security mandates, decades of legacy code. Jenkins isn't just fading away into obscurity. It is fiercely holding its ground in massive organizations that require heavy-duty, hyper-specific configurations that the newer, sleeker platforms simply can't handle. Okay, let's lift the hood on Jenkins for a minute. Jenkins operates on what's called a controller and agent architecture. The controller acts as the brain, the central hub, delegating all these complex build tasks out across multiple self-hosted agents. Enterprises absolutely love this setup because it provides literally infinite control. Need to compile firmware for medical devices by connecting an agent to a physical, literal hardware test bench in a lab? Jenkins can do that. Do you have strict air-gap security requirements where your source code absolutely cannot leave your physical data center? Jenkins is your answer. You own the hardware, you own the network, and you own the execution. But keeping it real here, it's not always a clean architecture. In reality, teams usually end up with this messy, chaotic mix of legacy ClickOps freestyle jobs running right alongside newer declarative Jenkins file pipelines. And trying to standardize that kind of chaos across an entire enterprise, it is often an absolute nightmare. And that brings us right to the operational realities. The cost of having that infinite control is a massive, often hidden maintenance tax. Yes, you have access to over 1,800 plugins, which sounds incredible on paper until you enter what we lovingly call plugin hell. Picture this scenario. You apply a really critical security patch to an AWS credentials plugin. Standard stuff, right? But suddenly, it completely breaks the basic Git checkout step on 5 different staging servers in production. Maintaining Jenkins long-term almost inevitably leads to severe operational exhaustion. Your highly paid DevOps teams end up spending countless hours on manual server maintenance, doing complex security patching, and just testing dozens of plugins on a staging server just to ensure that upgrading the core controller won't completely halt the entire company's ability to ship code.
This technical divide also deeply impacts the day-to-day developer experience. On one side of the ring, Jenkins uses Groovy DSL scripting in its Jenkins files. Now, Groovy is Turing complete. That means you can script actual raw code in your pipeline. Loops, complex conditionals, dynamic API calls, custom error handling, you name it. Veteran engineers love this raw power. But it forces your everyday developers to learn a completely niche language just to handle their deployments. On the flip side, GitHub Actions relies on a declarative YAML structure. YAML is highly standardized, it's readable, and it's incredibly friendly for modern cloud-native workflows. However, it is inherently more restrictive. If you aren't really careful to break your YAML down into modular, reusable workflows, you can very easily end up with a 5,000-line, completely unreadable monster file. So YAML forces standardization for the sake of speed, but you definitely sacrifice the raw programmatic logic that Groovy gives you.
Which brings us to the core philosophy behind GitHub Actions. Think of it as event-driven, cloud-native automation that executes directly within the GitHub ecosystem. As we mentioned with platform gravity, it drastically reduces onboarding friction simply because it lives exactly where the code lives. But the real magic here, it's the event-driven nature. You aren't just triggering pipelines when someone pushes code anymore. You can trigger a full-blown deployment workflow when an issue gets labeled bug, or when a developer leaves a very specific comment on a pull request, or when a release is drafted. It natively blends your project management right in with your CI/CD. For a modern engineering team, this represents a monumental shift away from clunky, infrastructure-heavy automation, moving directly towards sleek, platform-native workflows.
And what GitHub Actions actually equips you with right out of the box is pretty staggering. First off, GitHub-hosted runners mean absolutely zero infrastructure management for your team. None. Plus, you have instant access to a marketplace packed with over 20,000 pre-built actions. Need to deploy to AWS? Need to scan a Docker container for vulnerabilities? You don't have to sit there and write a custom script. You just plug in an action and you're done. It also handles dependency caching beautifully, so your NPM install doesn't take 10 minutes every single time a developer pushes a minor tweak. Even better, it uses OIDC, that's OpenID Connect. This creates short-lived, highly secure identity links to your cloud provider. So instead of storing highly vulnerable static credentials that sit around waiting to be compromised, it's all temporary and secure. Through reusable workflows, your platform team can automatically enforce strict security policies across hundreds of repositories without breaking a sweat.
Now, let's be fair. It is certainly not all perfect. A major real-world friction point you'll hit with GitHub Actions is the visibility gap, particularly if you are running complex monorepo workflows. If you have a massive monorepo and you only want to trigger builds for the specific microservice folder that just changed, visualizing those complex concurrent dependencies gets incredibly messy very fast. And on top of that, local debugging is notoriously frustrating. Because there isn't a highly reliable official way to run a complex pipeline locally on your machine, developers often get stuck in this maddening loop of commit, push, fail, repeat just to test a single tiny YAML indentation fix. We've all been there, and it is exhausting.
To really understand how these two titans compare, let's put them head-to-head using a totally realistic scenario. Imagine your team is deploying a containerized Node.js API microservice. The steps here are pretty standard, but they're critical. First, you securely pull the code. Second, install dependencies while managing caching so the whole thing is fast. Third, run your automated test suites in parallel. Fourth, build the Docker artifact. And fifth, deploy that container out to a Kubernetes cluster while securely handling all your production secrets. Let's look at how each platform physically executes this exact workflow in the real world.
In Jenkins, executing this workflow requires you to actually provision and manage the build agents yourself. So imagine it's 4 p.m. on a Friday. Everyone is trying to go home, and 20 developers merge their code all at once. In Jenkins, your queue is going to completely gridlock unless you have spent weeks building out complex auto-scaling rules for your AWS instances. You are fundamentally managing compute capacity. Now look at GitHub Actions. This same workflow is entirely event-driven and serverless. GitHub instantly spins up 20 fresh, perfectly isolated cloud containers, executes the parallel test suites, builds the Docker images, and then just shuts everything down. It seamlessly scales to meet those massive spikes in demand without a single DevOps engineer needing to panic monitor server CPU usage.
Real quick, if you're enjoying this deep dive so far, consider giving this explainer a like and subscribing to DevOps Corner. We regularly release highly detailed DevOps and infrastructure explainers exactly like this one, designed to help you navigate real-world engineering challenges. All right, let's get back into it.
Okay, let's break down the total cost of ownership, because at the end of the day, this is where the real business decisions happen. Jenkins is widely known as free because, well, it has an open source license. But honestly, this is a very dangerous illusion. The true cost of Jenkins is the massive DevOps full-time equivalent, or FTE, overhead. Think about it. A senior DevOps engineer costs well over $150,000 a year. Having them waste 30% of their valuable time patching Jenkins servers and resolving bizarre plugging conflicts is a massive loss of high-value talent. On the other side, GitHub Actions has usage-based per-minute pricing. Yes, you pay for cloud compute time, but you have virtually zero maintenance overhead. For the vast majority of teams, the cost of engineering time is infinitely higher than the cost of cloud compute.
But there is a crucial break-even threshold you absolutely must know, and that number is 150,000. If your enterprise team is consuming around 150,000 build minutes per month, the financial math suddenly flips entirely. At this massive volume of usage, the SaaS per minute billing of GitHub Actions becomes astronomical. And this is exactly why major enterprise teams start creating hybrid models. They use GitHub Actions for the beautiful developer UI and the seamless workflow management, but they actually run self-hosted runners on their own internal Kubernetes clusters to control the raw compute costs. So at a large enough scale, Infrastructure ownership once again becomes a financial necessity.
Now, let's be real. Scaling either system brings some serious headaches from the trenches. Neither is perfect. With Jenkins, you suffer from constant upgrade anxiety. It's that nagging fear that a routine Sunday server patch is going to completely break a critical deployment pipeline from Monday morning. But with GitHub Actions, you face severe vendor lock-in. If your team writes 50,000 lines of GitHub Actions YAML utilizing hyper-specific marketplace actions, migrating away to GitLab or Bitbucket in the future is practically impossible. You are marrying the GitHub ecosystem, for better or worse. Both systems also require rigorous credential management to ensure secrets aren't accidentally exposed during complex monorepo parallel builds. So neither system is a magic bullet when you're scaling up to hundreds of developers.
To truly understand where we are right now, we have to zoom out and look at the whole 2026 landscape. We have evolved from manual ops into the era of Jenkins dominance into cloud-native GitHub Actions. But today, we are deep into the era of AI-assisted platform engineering and internal developer platforms, or IDPs. DevOps teams aren't just sitting around writing pipelines anymore, they are actively building self-service portals. A developer simply clicks a button and they instantly get a pre-configured repository with standardized, highly secure CICD pipelines automatically attached to it. Modern engineering teams now prioritize the developer experience above absolutely everything else. They want CICD to be this invisible, seamless utility that completely removes infrastructure roadblocks.
So, let's summarize the ultimate 2026 verdict here. If you are a fast-moving team, you're already hosting your code on GitHub, and you want minimal infrastructure management with blazing fast developer onboarding, GitHub Actions is the definitive default, hands down. But we must be absolutely clear, Jenkins isn't bad. It is simply a tool built for an era of heavy infrastructure. If you are a highly regulated enterprise, managing multiple version control systems, needing multi-cloud deployment workflows, air-gap security, or hardware-specific testing, Jenkins remains deeply embedded, highly capable, and practically mandatory.
I want to leave you with this thought to help evaluate your own team's maturity. Are you spending your precious engineering budget on maintaining pipelines or on actually shipping features? Think about it. Is your CI/CD pipeline a polished product you seamlessly deliver to your developers? Or is it an infrastructure burden you force them to maintain? Modern DevOps is all about empowering teams to ship value, not fight their tools. The right choice between Jenkins and GitHub Actions ultimately depends on how much raw control you truly need versus how much speed you are willing to embrace.
If you found this explainer helpful in mapping out your own CI/CD strategy, make sure to like and subscribe to DevOps Corner for more deep dives just like this one. We'd absolutely love to hear in the comments which tool your team is betting on for 2026 and what kind of battle scars you've picked up along the way. Thanks so much for watching and keep building.